Hello, this is Anthony with Copley Controls. Today we'll be talking about the Omron EtherCAT controller. We have an NJ301 commanding motion to a Copley Controls TE2 stepper drive. So this is a dual axis drive with two stepper motors. And let me go to CME. I'm connected right now to the TE2 over serial. And I have firmware version 5.28 inside of the drive. So some important settings, if we go to the control panel, we'll see that we're in stepper CAN mode on both axes, A and B. We don't have any faults, that's good. And if we go to amplifier network configuration, we have an ID, network ID of 1. So as long as this is non-zero, that's what you want for using the Omron controller. So now we will download the ESI file. So the firmware version is 5.28. So I type that in here, check the model number, and we're going to download the slots version. Click this button, then get ESI file. I have that right here. And if you're ever curious, like this website, it talks about flat or slot. The only difference is slots have the PDO mapping for the cyclic modes of operation. So it's always handy to use the slots version. Okay, so I started up Sysmac Studio, and you can see I have the trial version running. They give you 31 days free, so 1 month. On the online tab, I can connect directly to the controller via these methods. I use the Ethernet, direct Ethernet connection, and then I also followed this this helpful page, this tutorial on the Omron website for how to use direct Ethernet, the direct Ethernet utility. So just follow this this guide. Will walk you through how to set that up. So after I'm able to connect to the controller, I can double click on the EtherCAT tab. And right now I'm online. If I wanted to update the ESI file library of the controller, I'd just go offline by clicking that button. And then I'd right click on the controller and display the ESI file library. And as you can see, I have the TE2 ESI file installed. If I didn't, I'd just click install and then select the file. So I have that ESI file inside of the library. I'm going to go online. I'm going to right click and I'm going to select compare and merge with actual network configuration. It performed a scan and it found the TE2. So I'll click apply actual network configuration. Great, so that's how we would go online, scan the network, and find the drive. Okay, if we look here on the left, you can see this little red warning sign. It says at least one module needs to be connected to axis A. So if we click on the Edit Module Configuration button, see axis A and B. So let's add some modules here. If I go offline, I just double click on the cyclic synchronous position mode, M1 over here. And then I click on axis B, and I do the same thing. And now I can see the PDO mapping for that slot. So we downloaded the slots ESI file, and at the very end we have the PDO mapping selected, pre-configured for these cyclic modes. So that's what you're seeing here. So if I go up to this first tab, I click Edit PDO Mapping up here. Now I can see the full list of the PDOs that I can actually edit. So you see under here it says editable. That's good. That means it's the non-fixed. So I'll select this one here. The first transmit PDO would be one that we can read inputs. So let's say add a PDO entry, and I'll add the digital inputs. So here's the general purpose inputs, 2190. I'll add that to this PDO. Click apply, click OK. And now we have the general purpose inputs for the drive mapped to a non-fixed TPDO. So now, not only are we, getting all this information in the fixed PDO, but we have our own PDO that we edited up here with the inputs, digital inputs for the drive. Okay, great, and that's how you would assign a module to the axes and edit the PDO mapping. If I go online with this, click the online button. Now we're activating this configuration. And I should be able to see all of the PDOs and their values. So let me click the download to controller button, execute that. Okay, great. Now we can see all of the PDO data across the network. So here's the status word. Here's the right there for both axes. And then we can see a control word here. If I change this to 15, now we can see that the status word changes to enabled. So that's good. We do the same thing over here. Yeah, we can see that axis B also is enabled. So if I go in here, we see that we're enabled on axis A, and we're enabled on axis B. One point that I would like to add is that before you set this value to 15 to enable the drive, make sure that your target position matches where you currently are, your actual position, because the minute the nanosecond you go and set the control word to 15, the drive will be in CSP mode, and this controller, the Omron controller, will be sending the target position down to the drive, and the drive will attempt to go there. So just make sure that before you do this 15, enabling the drive, you adjust the target position to match your actual motor position. And it just so happened that these do match. They're both starting at 0. So that's why we didn't generate any kind of following errors when we enable the drive. So that's how cyclic synchronous position mode works, is the controller will send target positions every update on the network. So actually, if I change this target position to some other value, let's say 50, now the drive actually goes there. See how that works? So I say 50, I could say 100, and the drive goes to that position. You don't want to make too big of a jump in this, using the PDOs, like using the IO map. You don't want to like jump to position 1,000,000 starting at 0, because then you'd get a following error. You would do that in like a function block, in a programmatic, using a PLC program, and we'll do that in a future step. But this is an excellent way to test that your system's well tuned. You're going to the target position, and you're enabled, and things are working properly. Okay, the next step is to create a motion control setup. So under motion control setup, we'll go to the axis settings, and we'll add a motion control axis. And that's for axis A, and we'll do another one for axis B. If we double click on that, here we have the basic settings. So this is going to be a used axis, and it's not going to be virtual. It's going to be, we're going to change the axis type to servo, and then now we're going to assign the different modules. So we're going to use the fixed, from slot 0, because this is axis A. So this is the first fixed PDO. We'll do the same thing for the R PDO here. And then down here, if you open up detailed settings, open this up, you have to tell it where to get the control word. So it's that same slot 0, and it's going to be the control word. And same thing with the target position. Oh, okay. And then for the inputs, you have to tell it where the status word is. Okay. All right, that was axis A. Let me double click this one, go to axis B, do the same thing. This time we're going to select slot 1 for axis B. Okay, great. So going back to axis A, save this. Let's click on these other tabs here. So this is just like we need to be in pulsing, so it's a encoder. This is like if you have a gear ratio. If they're the same number, these cancel each other out, so it's fine. Let me set these to some different values. So the max velocity, I'll set to 50,000. Start velocity. Okay. Everything else looks good. Okay. Looks fine. No software limits. We won't be homing. Rotary. Yeah, we're in rotary mode. Okay. And that's fine. Okay. I'm going to go to axis B. Okay. All right, let me save this. Okay, and that should be everything you'd need for the axis control. Okay, now that we have the motion control setup finished, we can move on to creating the structured text program. So the first rung in our ladder logic program, we'll right click and insert an input. This will be a global variable, a toggle bit that we can use to enable this rung. So we'll call this one drive enable, make it a global. And then over here, we'll use a ladder logic function block here. So first we'll do the reset. So if we have any faults, this will clear them. So we'll say axis A. Okay. Same thing for axis B. And we'll actually enable the axes. That's what the MC power function block does. Okay, so this should clear the faults and then enable the drive, both axes of the drive. So insert a rung below this, and we'll call this enable motion. This will be axis A. The enter key. We'll move 10,000 counts. I'll just use that same number for all the trajectory limits. Then I'll do a relative move here. So we'll say move busy flag. That'll be an internal variable. Move active flag. Okay. We'll do the same step again. Now we'll do it for going in the other direction. So now we're going back 10,000 counts in the other direction to put us back where we were originally. I'm going to go ahead and click and drag over here, and we'll paste, and this will be for axis B. So we'll be moving simultaneously both axes. It's pretty cool. Let me rename this. Okay. Great. So now we've got move 1 and 2 for both axes. They're both going to get triggered at the same time. 10,000 counts relative in the positive direction and then in the negative direction. So that's enabling motion. First we're going to do the drive enable step. Let me go ahead and save this, and then I will rebuild the controller, the project. Great, there were no build errors. Let me go ahead and go online. And I'll click the Download to Controller button. Okay, great. So now I'll go ahead and enable the drive. So now it executed this entire rung. So we're enabled for motion. I'll go ahead and toggle this, and I can see it here visually, but let me open up the scope. We can see that a move was made, and in CSP mode, every millisecond we got a new position coming in from the Omron controller, and the Copley servo drive was able to get there. So right now I have interpolation turned on inside of the drive. So that's through the objects 60C2, subindex 1 and 2. I'll show you how to turn on interpolation, and we can see that now we're interpolating between these positions. This blue right here, this is the Omron controller sending a position every millisecond, and then the Copley drive, its control loop, it is updating every 250 microseconds. So it's able to thread the needle, as it were, interpolating. You get more of a straight line profile instead of a staircase, so smoother motion. So yeah, this is how you would do a dual axis move in the Omron structured or ladder logic PLC programming. Okay, now we're going to turn on interpolation in the drive. So the interpolation time period is 60C2. We set these two objects to turn on interpolation. We have to make sure the interpolation time matches the PDO update rate of the EtherCAT network. So that's 1 millisecond, so that's what we'll be setting this value to. To do that, we're going to set 60C2 subindex 1 to a value of 1, and then we're going to be setting 60C2 subindex 2 to a value of -3. So that's 1 times 10 to the -3 seconds is 1 millisecond. Okay, I'm going to put the SDO rung here. This will be for the SDO function blocks. SDO settings, enable, make it a global. Then we'll insert a function block in here, say EC SDO write, hit enter. Now I'll put in the node ID of 1 to target the Copley drive. The object, we'll use a variable here. This will be we're going to populate that variable with a value. And the same thing here, write object. This is an internal variable. The data type is a US int because that's the object in the object dictionary. That's how big it is. 1 byte, right? Unsigned byte. Okay. And then I have to give this a name. It has to be a unique name. So we'll say SDO 1. Okay, great. Now I'll go and look at these variables, expanding that. And here are the new internal variables that I have. Let me give them an initial value. So in here, I'm going to put the 60 C2 object index, and then subindex 1. Great. I'll put OK there. And then it's going to be a value of 1 for that one. So that's good. And then I'll do the same thing. I'm just going to copy and paste this here. A lot of these are the same. I'm going to give this a unique internal variable. Okay. So this is the object. This will be for subindex 2 that I want to set to -3. So over here, so -3, so subindex 60C2, subindex 2. Okay. And then I go in here. So a value of -3, it's an unsigned, so I can't put that in there like -3. I actually have to figure out what that is in hex. FD is the hex value for -3. And then for like a byte. And then you'd convert that to decimal, which is 253. So put that in here. And that's it. That'll set the interpolation time period for axis A. So if you want to do the same thing with axis B, you just do the exact same operation, but instead of 60 C2, you target 68 C2. You always give an 800 offset for the different axes of the drive when you're targeting these parameters. So I'm going to go ahead and copy and paste. Let me copy this one, put it over here, and I'm going to give it a unique SDO object. This will be an internal variable. So down here, that same thing here, 1668 C2, subindex 1. Okay, and then the same thing here. Okay, and yeah, so let me do this here. Okay, and then let me make these unique instances. So give them unique names. Okay. All right, and that's how you would set the interpolation time in both axes of this controller, so of the drive. Let me save that, and we'll rebuild. Now we're going online, and we will download to the controller. Great. Now I can go in here, toggle this, and we see that all of those SDOs were successfully sent. So that's how you'd send SDOs one time on startup using a rung in your ladder logic program. So now this is the finished product. So go ahead and send our SDOs, and then we will enable the drive. Both axes of the drive will clear the faults and enable, and then we can go ahead and enable motion. So if I were to, let's expand this trace time, I'm connected over serial. So yeah, and there's the move. So we move to this position, 10,000, then we move back down to the 0 position. So yeah, that's how you would make a dual axis move using the Omron PLC with the Copley TE2 drive.